This is a video for MEI Core Pure Mathematics, Matrices 5, 3x3 determinants and inverses. 5.3 Inverse of a 3x3 matrix. Before we look at the inverse of a 3x3 matrix, we're just going to check out this idea of the transpose of a matrix. If I've got this matrix here, A, then the transpose of that is simply formed by taking every row and turning it into a column. So here, the first row has become the first column in the transpose. The second row has become the second column, and so on. Third row, third column. Now, in fact, it doesn't matter which way round you do the transpose. You might prefer to think of it as rows becoming columns or as columns becoming rows. It's entirely up to you. It's an interchange between rows and columns. So we can now lay out finding the inverse of a 3x3 matrix into a number of steps. The first thing is to calculate the determinant of the matrix. Choose your row or column carefully for the expansion, and remember that you might need to find up to 3 cofactors. If there are some zeros, you can save yourself some calculation by choosing the row or column that contains one or more zeros. You then go on to find the cofactor of every element in the matrix, and remember you may already have found up to 3 of those. You then build a new matrix replacing each element with its cofactor, and then transpose the cofactor matrix to form, we call it either the adjunct or the adjoint. And finally, divide by the determinant to find the inverse matrix. And this is where this first step is so important. If the determinant is equal to 0, then dividing by the determinant is going to give us a problem. And in fact, we can just simply say that there is no inverse for this matrix if its determinant is 0. So if this happens, and the first step will be to check that, if this happens, you don't need to do the rest of this because you've got no inverse for this particular matrix. So let's try and find the inverse of this matrix at M. First thing to note is I've got no zeros, so there's no advantage to picking any particular row or column. And in fact, as I've said previously, I'm going to expand about the first row. So I want these cofactors, A1, B1 and C1. A1 is just going to be this determinant, so it's 1, 4, 3, minus 2. And that's going to be minus 2, take away 12 is minus 14. B1 has a minus of this determinant, 2, 4, 4, minus 2. And that's minus 4, take away 16 is minus 20, and I get a sign change. And finally, C1 is the determinant 2, 1, 4, 3. No sign change in that. So that's 6, take away 4 is 2. And so now if we look at the determinant of M, I get A1, A1, so that's going to be 1 times minus 14, plus B1, B1 is going to be minus 4 times 20, plus C1, C1 is going to be 2 times 2. Working those out, we get minus 14 minus 80 plus 4, which gives me minus 90. So the first thing to note is the determinant is not 0, so we do need to carry on and do the rest of the calculation. I want the remaining cofactors now, so I want A2 and A3. I'm going to want B2 and B3, and I'm going to want C2 and C3. I'm not going to go through all of that calculation here, but I'll show you the results of that on the next slide. So there's all of that worked out and written up neatly for you. There's my matrix. That's the first row cofactors, as we saw on the previous slide, and the determinant therefore. And then these are the other cofactors. here, second row, and the third row cofactors. Now you could pause at this point and see if you could make sure that you agree with these for the other cofactors. So moving on from there then, this is effectively my matrix of cofactors arranged here, and to form the adjoint I'm just going to transpose this matrix of cofactors. So the first row is going to become the first column here in my adjoint. The second row, that's these values, becomes the second column, and similarly for the third row becomes this column here. My inverse, final step, my inverse then is to divide by the determinant. If you remember, that was minus 90. So I get 1 over minus 90 times the adjoint of m. Now this minus 90 outside here, you could take that minus sign inside the matrix and it will affect every single element in the matrix. So you could write your inverse like that, but it's really not necessary most of the time. Okay, so let's see if we can find the inverse of this matrix then. And the first thing I'm going to do is to form the matrix of cofactors. Actually, before that, I want to find the determinant, but I'm going to find a couple of cofactors first of all. I'm going to expand about this row, the second row, so I'm going to form the cofactors for the second row. So if I start with this one, I'm going to get its cofactor will be minus 1, take away minus 2, so that's 1, and it's affected by a minus sign, so that will be minus 1. For this element, I'm going to calculate it anyway. It's going to be k minus 3, and there's no sign change. And for this element, it's going to be minus 2k, take away minus 3, so it's minus 2k plus 3, but there is a sign change, so I'm going to get a 2k minus 3. Now let's have a look at the determinant of A then. So the determinant of A, expanding about the second row, is just going to be 1 times minus 1. I'm going to get nothing from the middle term, and then I'm going to get plus 1 times 2k minus 3. So working that on through, I get minus 1 minus 2k plus 3, which is 2 minus 2k. And now, provided k is not equal to 1, this thing will be non-zero. And therefore, I shall go on and calculate the remainder of the inverse. So filling the rest of these in then, I'm going to get minus 2, minus 4, minus 2 from the first row, and I'm going to get 1, k plus 1, and 1 from the last row. I now want the transpose of that, the adjoint matrix. So the transpose of that is going to take the first row and turn it into a column, so minus 2, minus 4, minus 2. Second row, minus 1, k minus 3, 2k minus 3. And the last row, 1, k plus 1, 1. And so my inverse is going to be 1 over the determinant times the adjoint, which is minus 2, minus 1, 1, minus 4, k minus 3, k plus 1, minus 2, 2k minus 3, 1. Again, there's that written up neatly for you. The determinant calculation isn't on here, but you can see there's the confirmation of the determinant as 2 minus 2k. So your matrix of cofactors, the transpose of that, and then this gives you the inverse of the matrix. That was the final video in the sequence Matrices 5, 3 by 3 determinants and inverses.